Hi guys, welcome back to Swipe to Learn. Today we are back with another video in our DBMS series. We have discussed about what is our DBMS, its rules and how our DBMS is used and the different types of keys. Now we'll be seeing about relational algebra and relational calculus in this video. So what is relational algebra? It's a simple procedural query language used to query the database. Like input is some relation from which the data has to be accessed, and output is also a relation. Like you need to function something and you need to retrieve some part of the data. That is called as relational algebra. Like if you see with this table, we have column ID, name, and age. I need the students with age less than 17. What my values would be 19 and 13. I want only the names. So Ccon and less than 19, 15 and 13. Ccon and Dcon will be the result. So input will be a relation and output will always be a relation. This is how relational algebra works. It works on complete table. Like we don't need loops or iterating each and every row. For a single operation, it works on the complete table at once. The major primary operations that we can perform using relational algebra are select, project, union, set difference, Cartesian product, and rename. We'll see about each of these 6 different operations in detail in this video. So let's get started. So we have classified the operations in relational algebra as basic operations and derived. Basic are selection, projection, renaming, cross product, set difference, and union. Whereas derived joins, intersection, division. We'll see about this derived operations in the future coming videos in detail. So what is select? This is used to fetch rows from the table with satisfying the certain condition. Like what is the syntax? You call it as sigma p of r. What is sigma? Sigma is the select predicate. Predicate means before. It indicates the selecting. What you are selecting? R. R is the relation. Like the table name in from which table you are performing. And P is the preposition logic. Like on what logic you are using. Like in the logic we can use equal to all binary operators, equal to, less than, greater than, everything. Sigma P of R is the syntax for this. Sigma will be the select predicate, P indicates the logic, and R will be the relational table on which you are performing the select operation. So in the previous scene example, we need all the data whose age is less than 17, or now we are taking all age more than 17 here. So how I can write is sigma age greater than 17. So what is sigma? Sigma is select predicted. What is my preposition logic here? Age. I want age should be 17. From which table? What is my relation? This is my table, right? I need to name the table as student. So what will be the result? Greater than 17. I have only beacon. So I need all the values age greater than 17 and gender is male. So I can write it as here. So what is my predicate logic here? Age greater than 17 and gender equals to male. This is my predicate logic. By changing predicate logic, you'll get all. Even with this, I'll get my output will be as beacon. Right. So this is how we use the select. Now let's go with project. Project is used to only get the certain set of attributes of a relation. Like we get the columns or attributes asked for, and it removes the duplicate data. So in the same way of sigma, we have the project symbol pi, and what are the attributes you want, the columns you want, column name C1, C2, of which table you specify the relation. This is how the syntax works. So A1, A2 are the attribute names, and R will be the of course relation model. If I say pi of name comma age from the table student, R will be student, I'll get the values of name comma age. That is how project. We cut down the columns. We used to This is used to retrieve only particular columns. Now what is union? Union is used to fetch data from the two tables. Like this is it generates the temporary relation. It takes table 1, table 2, and it performs the union operation and results the table 3. This table T3 will be the temporary table. Okay. But to perform the two table, all the set operations, union, intersect, Cartesian product, to perform the operation on two different tables, it should have the same number of attributes and same attribute domains. What is the syntax? Syntax is very simple. A union B, where A and B are the two relations. I have the table course 1 with attribute name CID and CNAME, and the table course 2 with CID and CNAME. I need to have same attribute CID and CNAME. So what my union looks like? I need all the data. So I need 1 1, 2 1, 3 1. I'll write 1 1, 2 1, 3 1. And their CNAME. In this 1 2, 1 2 is unique. I have added. Whereas 2 1, it is duplicate value. I already have 2 1 and C++, right? So I'm taking all them. It removes the duplicates. Union always remove the duplicate. And I'm taking the entire, all the set will be there in this union. And what is set difference? If you see with the operations like A union B, A minus B, same as set it works. The operation is used to find data that is present in one relation and not present in the other relation. Like what is A minus B? It should present in A and it should not present in B. If you say A and B, this left part will be the A minus B, where A and B are relation. In this course 1, course 2, I don't have 1, 2. Here, check for 1, 2. I don't have course ID 1, 2 and Python here. 2, 1 and C++. I have this. So I'll won't include this. I'll remove this. And here comes my A minus B table, course 1 minus course 2. 1, 1 and 3, 1 with their courses. This is how set difference operation works. Now let's move on to next, Cartesian product. It's like cross product. This is used to combine data from two different table into one data. It also poses the duplicate values too. If you say with student and course, for Andrew, class 5, class 25, for this set of row, I'll take all the rows from the other table. Like this may contain same data, I mean same attributes or different attributes, no problem. For this Andrew 1, Andrew 525, this tuple, I'll be adding 11 foundation C and 21 C plus one set. Like if we have 3 rows, 3, 2, it will be 3 into 2, 6 tuple values would be there. And for the student ID 2 and angel and 10, 30, for this we add both the courses 1 1 foundation C and 2 1 C++. The same for third round. So if it has n into m, then the rows would be n into m. Okay. Rename. This operation is used to rename the output relation. Like we denote the symbol this and relation new of old. So I need to rename a table. Like I need to rename the member table into new as library member. New relation. See member to library member. So my table name would be library member here. Previously it will be member. To rename we use the same like select and project, we use this symbol with this syntax. Congratulations on starting and learning about RDBMS and relational algebra. Let your code flow like well structured. If you haven't seen up about our previous videos, will be you have a glance on all the videos, and in the coming videos we'll be going into the coding part of using an SQL processing language and how the data is retrieved and how tables are created, used, everything in detail, and all the operations, DDL, DML queries, everything will be performing in the next coming videos. So stay tuned to first Swipe to Learn for more interesting videos in DBMS. We'll be completing the complete overall concept of DBMS in the next coming future videos. Thank you guys for watching. Please do like, share, and subscribe and comment at the rate of Swipe to Learn. Thank you guys.